Hey all, this is part 9 of most repeated questions in SAT. So let's move forward. This is something which will surely benefit you when to use 30 60 90, when to use 45 45 90. So I have summarized everything in one page, and you can take the screenshot of that and you can practice a few questions based on that. Okay, but if you are new to the channel, make sure you're subscribing it so that you can make the notes of each and every concept and you can be active on the channel whenever I post a new video. Even I have made a WhatsApp group for the Indian students, a kind of announcement group, a channel you can say. So you can join that, wherein you will get the updates of these questions. Also, if you need documents or the questions in the PDF form, I'm going to share you there. Okay, so there are many more surprises for you for upcoming SAT. Make sure that you are not missing that. So let's move forward now. And here comes the summary of when to use 30 60 90 and where we can use 45 45 90. Very important, because you know the concept, but if you're not implementing it, if you don't know how to implement and where to implement, trust me, that will not help you. This is not going to be useful for you then. So always remember, whenever you see there is a circle and equilateral triangle is inscribed inside a circle, sorry, or circle is inscribed inside a equilateral triangle, in that case you will always get 30 60 90 triangle. Okay, so remember this point and remember this 30 60 90. Second is, whenever you see square is inscribed or circle is inscribed in a square or square is inscribed in a circle, immediately you will understand that it is going to be 45 45 90. If it is a regular hexagon, then it is going to be 30 60 90 rule, right? Now, circle inscribed in a square, there is a thing that many of you get confused. Suppose there is a circle. Let me take the shapes and show it to you. There is a square and there is a circle. Okay? Let's assume that this circle is inscribed in a square. So whenever circle is inscribed in a square, you can clearly see from here that the side length of the square is nothing but the diameter of the circle, right? And if it is given that square is inscribed in a circle, let's say this is a circle and here I have a square. Now if square is inscribed in a circle, that means the diagonal of the square is equal to the diameter of the circle. Okay, let's assume this only. If you're drawing a diagonal, it is nothing but the diameter of the circle, right? Each point should connected with the points of the circle. Okay, so that these are the basic concepts. Please take a screenshot because this is going to help you for sure, and or note it down somewhere. Okay, when to use 30 60 90 and when to use 45 45 90. Now let's practice some questions. So in this question, it is given a square is inscribed in a circle. There is a square and it is inscribed in a circle. Let's do it. There is a circle and square is there inside the circle. Perfect. Right? A square is inscribed in a circle. Now, and remember, whenever square is inscribed in a circle, the diagonal of the square is equal to the diameter. That was the case that we have studied just now. What is given? The radius of the circle is given, which is 20 root 2 by 2. This is the radius. Always remember to write what is given. That will actually give you a clear picture. 20 root 2 over 2. You don't have to read question again then. What is the side length? They are asking you to find out the side length in inches of the square. Now, can I say diameter is nothing but twice of radius? So radius would be 20. If radius is given, diameter would be 20 root 2, right? Diameter means the diagonal of a circle is 20 root 2. 20 root 2. Now remember, I told you one more thing. Whenever square is inscribed in a circle or circle is inscribed in a square, we always get 45, 45, 90-degree angles. If this is 90, then these two angles are 45, 45. Right? Now, that means if these two angles are 45, the side opposite to these angles will be x and side opposite to 90 will be root 2x. Side opposite to 90 is already given. Side opposite to 90 is 20 root 2. That means it is 20 root 2. So can I say instead of x I can write 20? That means the side opposite to 45 will be 20. So this is 20. This is 20. Can I say the side of the square is 20? Yes. You don't need to apply any Pythagoras theorem or anything like that. You can take help of 45, 45, 90 and directly get your answer. That is the best method to solve these kind of questions. And please make sure if you still didn't understand these special triangles, because using special triangles, you can solve at least 3 to 4 questions in your SAT for sure, including the questions in both the modules. Okay. Coming to question number 2, now there is a concept of an equilateral triangle and circle. We are talking about equilateral triangle and a circle. Let's see. An equilateral triangle has a perimeter of 324 centimeter. There is a equilateral triangle and the three vertices of the triangle lies on the circumference of the circle. That means triangle is inscribed in a circle. So let's try to visualize it by drawing the figures. That is something I consider as the best method. Now, and whenever you're doing it in your SAT, you have to be very quick. That's all. Okay, this is a triangle. Perfect. It's an equilateral triangle. So, one thing is given clearly that the perimeter is 324. Can I find out the side length? Even that is not important right now, but yeah, you can. So, side of, let's say this is A, B, C. If you are adding, doing AB plus BC plus CA, it will give you 324. Can I say 324 divided by 3 gives me the side? What is that? You divide it and tell me what you will get. 108. That means each side is of 108, because when you add 108 three times, you will get the perimeter as 324. Now, let's try the concept of special triangle. I told you whenever equilateral triangle is inscribed in a circle or circle is inscribed in an equilateral triangle, we get 30, 60, 90 special triangle. How? Let me show you here. So, what I'm going to do, you know that each angle is 30 degree 60 degree, sorry, all angles are 60 degrees. So I'll draw a bisector and join the center. This is the center of the circle. From here I'll draw a perpendicular line because I need a right angle triangle, then only I can apply that special triangle concept. Okay, I got one 90-degree angle. This is an angle bisector, that means it divides angle into two equal parts. Initially this angle B was of 60 degree, now it is 30, 30. So this is 30, this is 60. Obviously if one is 90, other is 30, the remaining angle will be 60. Right? Now, the total side is already given. You find out that each side is of 108 centimeters. Since this is the center, what is half of 108? Correct, it's 54. So can I say the side opposite to 60 is what? 54. Right? Now write it down in the general form. This is x, this is root 3x, and this is 2x. Right? What is the other way of writing this? If let's say if the side opposite to 60 is x, then side opposite to 30 will be x over root 3, and side opposite to 90 will be 2x over root 3. That's what I need to write. If side opposite to 60 is 54, then side opposite to 30, I'll just replace the value of x with 54. So it will be 54 over root 3. And this is going to be, what is 54 times 2? 108. 108 over root 3. What are they asking in the question? Because I got the length of all the three sides of this triangle OBD. So what are they asking? Find the radius of the circle. That means they are asking to find OB. OB is the radius. Side opposite to 90 is the radius. Side opposite to 90 is 108 root 3. So option B will be our answer. I hope it is easy for you. Do let me know, because this is the easiest method using which we can solve these difficult questions. So that's all for today, and I'm going to see you with some more Desmos tricks. Part 9 is already done. I'll see you in part 10, and till then, make sure that you're revising all the all the questions that we have done till now, and practice them as much as you can. So that's all for today. Bye bye. See you in the next video.